In this video we will take a look at parallel and perpendicular lines. Parallel lines. Lines are parallel if they all are always the same distance apart, called equidistance, and will never meet. The red and blue lines are parallel in both these examples. If we call the gradient of the red line m1 and the gradient of the blue line m2, in both cases, because the lines are parallel, we can state that the gradients are equal, therefore m1 is equal to m2, and this is always true for parallel lines. It is possible to have parallel curves. Curves can also be parallel when they keep the same distance apart, called equidistant, like railway tracks. The red curve is parallel to the blue curve in both cases. Perpendicular lines. Perpendicular, it just means at right angles. The red line is perpendicular to the blue line in both cases. The angle between them is 90 degrees. If we call the gradient of the red line m1 and the gradient of the blue line m2 in both cases, because the lines are perpendicular, we can say that m1 times m2 is equal to minus 1, always true for perpendicular lines. Therefore, m1 is equal to minus 1 over m2. In other words, the perpendicular lines are the negative reciprocal of each other. This is always true for perpendicular lines. Let's go through some examples. 1. Find the gradient of L2 perpendicular to L1 with gradient A m equals 2. So we know for perpendicular lines that m1 is equal to minus 1 over m2, in other words, the negative reciprocal. Well, we could write 2 as 2 over 1. Therefore, m2 is equal to minus 1 over 2. The reciprocal, we just flip the fraction over. B, m is equal to minus 3 over 4. So m1 is minus 3 over 4. So m2 is the negative reciprocal. It's already negative, so make it positive. Flip the fraction upside down, so it becomes 4 over 3. And C, m is equal to minus 9, which we can write as minus 9 over 1. So m1 is equal to minus 9. So m2 is a negative reciprocal, so we make it positive, flip it upside down, so it becomes 1 over 9. And I'd like to do just one more. D, m is equal to 0. Well, we could write that as 0 over 1. So we know that m1 is 0. So m2 is a negative reciprocal, which is 1 over 0. But we can't divide by 0. So therefore, m2 in this case is undefined. Question 2. State whether the lines are parallel, perpendicular, or neither. In order to do these, we need to compare the gradients, so they need to be written in the form y equals mx plus c. A, y equals 5x plus 7 and y equals minus 1/5 x plus 2. Well, the gradient of the first line, m1, is equal to 5. The gradient of the second line, m2, is equal to minus 1/5. m1 times m2 is equal to minus 1, therefore perpendicular. Part B. The first line is 3x minus 2y plus 6 equals 0. The second line is y equals minus 3 over 2x minus 6. If we rearrange the first equation, we get 2y is equal to 3x plus 6. So y is equal to 3 over 2x plus 3. So the gradient m1 is equal to 3 over 2. The second line, it's already written as y equals mx plus c. So m2 is equal to minus 3 over 2. Well, it's not the negative reciprocal and they're not the same, therefore neither. And C, the first line, y minus 4 equals 4 brackets x plus 2. So if we expand that, we get y equals 4x plus 8 plus 4. Therefore, y equals 4x plus 12. If we rearrange the second line, we get y equals 4x plus 6. The gradient of m1 is equal to 4. The gradient of m2 is also equal to 4. m1 equals m2. Therefore, the lines are parallel. Question 3. Find the equation of the line parallel to the line y equals 2x plus 1 and passing through the point 5, 4. In order to find the equation of a line, we need a point. Well, we're given that, it's 5, 4. 2, we need a gradient m. Well, we can find that from the original line. Because they're parallel, it must have the same gradient as this line. So the gradient is 2. And 3, we use the formula y minus y1 equals m x minus x1. Substitute in our values, so we get y minus 4 is equal to 2 brackets x minus 5. So we get y minus 4 is equal to 2x minus 10. Add 4 to both sides, so we get y equals 2x minus 6. So the equation of the line parallel to 2x plus 1 passing through the point 5, 4 is the line y equals 2x minus 6. Question 4. Find the equation of the line perpendicular to the line y equals minus 4x plus 10 passing through 7, 2. So again, we need a point, which we've got. The point is 7, 2. Second thing we need is a gradient, which we can get from the line y equals minus 4x plus 10. Because they are perpendicular, we know it is the negative reciprocal, so it is already negative, so we make it positive, and the reciprocal of 4 is 1 over 4. And thirdly, we use the equation y minus y1 equals mx minus x1, substituting what we know, so we've got y minus 2 is equal to a quarter x minus 7. If we multiply out, we get y minus 2 is equal to a quarter x minus 7 over 4. Well, minus 2 is the same as minus 8 over 4, which is equal to a quarter x minus 7 over 4. If we add 8 over 4 to both sides, we get the line y equals a quarter x minus 7 over 4 plus 8 over 4 is plus a quarter. So the line perpendicular to the line minus 4x plus 10 passing through 7 over 2 is the line y equals a quarter x plus a quarter. Question 5. Find the gradient of the line passing through the points 2, 4 and 2, 1. If you draw a diagram of this line passing through those 2 points, 2, 4 and 2, 1, you will get a vertical line. Now if you use the gradient formula, we know that m is equal to y2 minus y1 over x2 minus x1. So m is equal to 4 minus 1 divided by 2 minus 2. So m is equal to 3 divided by 0. We know that you cannot divide by 0, so therefore m is undefined. All vertical lines have a gradient that we say is undefined.